Rob Allen with Stromquist and Company, here with Mahmoud and Mike from Panduit. Guys, welcome to the show.
Thanks Rob. Great to be here.
Glad to have you guys here. So full disclosure, found out that we were going to be interviewing Panduit, and I said, how are we going to fill all this time talking about wire ducts, right? So but clearly you guys do a lot more than just that. And then I found out at the general session on the first day when the lights went dim and this was a big unveiling, and they said this is going to be the technology of the future, and you watch, and all of a sudden it was Panduit, and I said that's really cool, and then I went, oh my gosh, I'm going to be interviewing those guys, no pressure. So I'm excited to talk to you guys, but quick, tell us a little bit about Panduit from just a company perspective and some of the solutions that you guys provide.
Sure, absolutely. So Panduit has been a part of the industry actually for a very long time. So some of those initial products, 70 years ago. So
wow.
Innovations in the control space, right? And then on the datacom space, 40 years of Panduit innovations there as well. So our tagline is infrastructure for a connected world. So we're all about the connectivity that connects your power and your data across IT and OT. We're pretty well known on the enterprise IT side for the solutions that Panduit has here at the booth around smart buildings. But we also have the power solutions, which are a big part of what we're working on today. And that's a big learning from Panduit as well around the power side.
Yeah, wow. So what an education. 70 years of doing great things, and clearly, what we're talking about in a minute, you guys are doing some even greater things. But I know you're making strides with smart building design and deployment. Tell us a little bit more about that.
I'm sorry?
Smart building designs and deployment.
Yeah, smart building designs and deployment, of course. So, PoE over the years has been used very effectively, right, to save on operating energy, even up to 40% energy savings with an all PoE infrastructure, right? But to really get to sustainability goals and some of the net zero mandates that are out there, we need to provide more of that DC conversion further back into the system, or leveling up our DC power capabilities. And that's really on the deployment side. Things like PoE are easier to deploy versus a line power solution, and so is the DC power solutions that we're talking about. They leverage that same low voltage infrastructure, very simple to install, very simple to maintain, but providing both material cost benefits as well as reducing operating expenses as well.
Wow, very good. Let's shift a little bit. Fault managed power systems. That was a new thing for me, and tell me a little bit about that and what a fault managed power system is.
Absolutely. First, did you enjoy the lighting surprise that we did?
Really cool. Actually, it was beyond really cool. It was something better than that. I'm excited.
I'm glad to hear that. Fault managed power, the concept has been around for years, and basically what it is when we talk about smart buildings or sustainable buildings, the first thing we need to address is eliminating AC to DC conversions. And the missing piece, all DC powered buildings have been around for a while, people have been talking about them, but in our opinion, the missing piece has been, how do you safely distribute DC in a building out to the last 100 meters or 50 meters where you're potentially doing PoE or class 2 power or some other method. And now fault managed power, and our solution is class 4, really fills that gap. So what fault managed power does is it takes DC and then it's distributing it all over your building. Our solution can go up to 2 kilometers away over skinny wires, skinny copper conductors, but it's safe enough where if somebody actually touches it, or if there's a short circuit or any kind of fault that could cause a shock or a fire, it actually detects it and turns that power off instantly.
Wow.
Within a maximum, our solution, within milliseconds.
Wow.
Thereby, making sure it doesn't cause a shock or cause a fire, and now that solves that distribution problem.
Wow. So it can isolate the issue, or it can detect the fault, shut it down, isolate it, so
Yes.
it's safe, right? Is that
Correct. It will detect per channel. It's multiple channels per copper pair. You think it will detect it will turn off and isolate. It's not going to cause an effect in any other distribution in the system. It's just that one channel on its own. Kind of like your breaker. The one breaker will turn off, but this is just much smarter and can detect a lot of different faults.
Wow. And so when we talk about DC and AC real quick, at DC, the reason that we went AC in the world, right, is it turned out to be better. But DC, what were the problems, limitations with DC, and then how have we solved those today?
Yeah, so there were basically two things that we couldn't solve back then. First, there was a talk about, you can't distribute DC for long distances because of the voltage drop. But that issue actually is true both for DC and AC. But they also talked about the lack of safety of DC, and that's why DC kind of lost that battle. But also, we didn't know how to manage DC in terms of being able to turn power off remotely.
Okay.
And those two things now have been solved. We've solved the safety issue or misconception, and now we're also able to manage these channels, so we're actually able to turn power on and off from our solution remotely.
Wow. And then you said something earlier, and I want to make sure we level set, but you said Class 4 power. Yeah. What is Class 4 power, and are you guys the only one that has Class 4 power?
But yes, that's true.
Wow.
So fault managed power is a way of detecting faults and being able to distribute DC or any form of power really. But then Class 4 is what actually makes it. Class 4 is a classification in the National Electrical Code.
Okay.
And that's new. So typically we have 3 classes of power, 1, 2, and 3. 1 is what's running in this venue here today and in our homes. 2 is PoE, is the most common form of Class 2. And then I'm going to skip 3 because it's mainly for home theater applications, etc. But now Class 4, which is just a year old, that's basically saying you can develop these fault-managed power systems, but you have to adhere to specific standards by UL that are also just a year old. And it just makes it, we believe that now that Class 4 is around, we hope that the adoption of this type of technology will make it easier for end users and developers, etc.
So is Class 4 data and power in one cable? Is that Class 4?
Class 4 basically says you can develop a system that can push up to 450 volts from the source, which is a lot. But you have to have a mechanism of detecting faults and turning off within specified time limits, and those are all governed by UL 1400-1 standard. So if you want to be Class 4 listed, go in and get a UL certified system.
So clearly you guys had sustainability in mind when you created this, right? So tell us a little bit more about why it's sustainable, what you like about it, what are some of the benefits of going this route?
Yeah, so from a sustainability perspective, we kind of see things that are going on in the industry here around convergence, right? And so the industry going to IP platforms from a service standpoint, a software standpoint, data aggregation and convergence among that, and then the low voltage systems or having a single platform, converged platform to be able to deploy all these systems critically important. And the role that plays then with sustainability is we can be visionary here, right? And we can say, what does this new building look like? And work with integrators, design consultants to help mold that so that, development now, we can meet a certain amount of applications, save a certain amount of power, but as time goes on, we can start to work together to build out like the DC microgrids, working in things like sustainability from renewable power perspective, having those in front of where like fault managed power goes so that we're integrating in more sustainable features and moving that AC to DC conversion further upstream so that we've got the best operating cost capability.
And I'll just add to that. So when you think about this concept of Class 4, I like to break it up into 2 separate benefits to the end user and the developer. Yeah. First, and this has the sustainability angle, you're able to distribute over thin copper, and the fact that it's safe allows you to make it a low voltage installation. That's a big part of it. You don't have to run this power in conduit anymore. Okay. So you're saving on all the conduit that's running in buildings. Wow. So when you talk about sustainability, it's 50% less mined materials from a less copper and a conduit perspective. But also you get the benefit of centralizing your power distribution. So end users now value a lot the fact that you can centrally back up your entire building from one spot using a UPS or using a battery bank. But also the theme of this show has been monitoring and control. And this power is, you have a power network that you can actually monitor down to the last device that you're powering, and you can control it remotely.
Wow, that's fascinating. And not to mention probably labor savings.
Absolutely. So you can have a low voltage contractor. In many cases now, in smart buildings, you have connected devices at the edge that need bandwidth. So you're running some form of data cable, whether it's category or fiber, and you need power with it. So that same contractor that's already there pulling that fiber or data can pull the copper cable as well. So when we've done some studies, we see about 40% in savings from material and installation costs just from that.
Excellent. So we're out of time, but I want to give you about 15 more seconds, whoever wants to take this question. But we're at Realcomm, a lot of building-centered, focused stuff here. Why should someone adopt this technology for their building?
Yeah, I can certainly take that. So really, this technology is available today, and a lot of people look at it and think this is magic, but it's not. And the fact that it's class 4 and it's in the code, we're hoping that people can see this is legitimate product. This is certified. It's certified by UL, and so the technology is here. And why you should adopt it, because we talked. This is your way to get to net zero goals. This is the way to achieve your sustainability goals. And even not even just from a new building perspective, even if you're doing retrofit, this really is a great solution for that, because we're solving problems of you need power in different locations nowadays to add more connectivity at the edge. And this is your way to do it very easily, very fast to deploy, using cheaper labor, less material, and then you get the benefit of being able to back up your systems centrally, which saves a lot of money as well. Just the maintenance and operation of that is really key.
Well said. Man, that was a great pitch. Very good.
I hope it works.
Yeah, good job. Fascinating stuff. Thank you guys so much. I definitely believe what Jim Young said, that this is definitely the technology of the future. This is the next big thing. And so I'm so happy I got to interview you guys. Thank you so much for coming on the show.
Thank you for having us.
Realcomm. Thank you. We're out.